It's include many lessons such as vibrational motion. Before I talk about wave motion, I should explain it more accurate. What's meaning by wave motion? Wave motion, it's a motion of waves, but to be more accurate, I should explain what is the motion. Motion, it's change the position from one point to another point by passing time. In the other meaning, motion, it's changing in position by passing time. What about wave motion? Wave motion, to know it, I should explain vibrational motion or circular motion in the following lessons. At first, we have two types of motion. The two types of motion: translational motion and periodic motion. Translational motion, that is not our concern, because we talk about in the previous stages, like the change in the position from point to another point in a straight line, like the train travel from certain station to another station from 10 a.m. To 11 a.m. I mean in a certain time, but we should know in the straight line, but period time, it's different. It's different in the meaning. I can now make share screen to see what I say. You can see it, Ahmed?
Yes.
Again, the two types of motion: transitional motion and periodic motion. Transitional motion, it's meaning the transition in the object position from one point to another point by passing time. Periodic motion, it's repeating the motion in certain periodics of time. It's can classify into wave motion and periodic motion. Wave motion, like throwing a stone in a still water, it make group of waves, they join in the center but different in radius or in parameter or in area, but the source of all group of waves is one. What is it? A stone that's throwing in still water. Second example, pushing a piece of domino. What can occur after that?
The pieces after the pushed piece will be pushed.
Why?
Because the first piece, the first piece push the second piece, and the second push the third push the fourth, and so on.
This experiment shows or illustrate or prove a law It's very, very, very popular in physics. We talk about in first grade, secondary, and third prep, and so on. What is the law we talk about that makes the first push the second, and the second push the third, and so on?
Uh, I don't remember.
Okay, no problem. This law is the law of conservation of energy. Do you remember?
Yeah.
Okay. What it was say?
Say that the energy transfer from
One object to another.
one object to another.
Okay, but it can't be destroyed nor created.
Can be destroyed, nor created.
Can't, not can. Can't be
Can't,
created
can't
nor
be
destroyed. Or
destroyed
can't be
nor created.
destroyed nor. Then there is no energy once, or it finish. No, it just transfer from one object to another, from one state to another state. Okay.
Okay.
Then we have a definition for a wave. What's meaning by wave? By watching the screen or the slide, wave, it's meaning it's the disturbance. What's meaning by disturbance? Disturbance, like noise, like weird something, because the object, uh, according to first law of Newton, need or prefer to stay constant, not move in somewhere. No. And the other, on the other hand, the moving object prefer to stay moving, and the constant object prefer to still constant. This was the first Newton law says in secondary one, if you remember. Okay.
Yes.
Then wave, it's a disturbance which propagate and carries energy in the direction of its propagation. So if the first piece of domino move to the right direction, then the energy direction in the right direction. Okay.
Okay.
Okay. Types of waves. Some waves can be seen, such as water waves, and this is more common or more popular. Other waves can't be seen, but we detect them by such as radio waves and TV waves. What is the other types of waves, if you know, if you have any idea about that?
Sound wave.
Okay. Sound wave, we can't see it, right?
Yes.
Okay. Sound wave, light wave. Continue.
Uh, the sound wave, the light wave.
Okay, no problem. That's enough. So waves can classify into two types of waves: mechanical waves and electromagnetic waves. Now we can talk about mechanical wave. Mechanical wave can also classify into two sections or two parts: transverse waves and longitudinal waves. Transverse waves, like water waves. at first we talk about هيقول ايه okay transverse waves like water waves and longitudinal wave like sound waves, but when we talk about electromagnetic waves, it has also type of transverse waves like radio waves. So we can say every electromagnetic wave it's be a transverse waves, and not every transverse wave can be electromagnetic wave. Do you understand
True.
me? Okay.
Yes.
And all the mechanical wave, not longitudinal wave, but all longitudinal wave are mechanical waves. Okay.
Okay.
Excellent. Bravo. First mechanical wave, it's a disturbance that propagates in materialistic media. What's meaning by materialistic media? Like what? What?
Media
About?
like water, air.
Okay. Okay. Then we talk about gaseous state or liquid state or solid state, right? Okay.
Right.
Okay. In the next words, I will ask you what's be more fast for mechanical wave to move in. Okay. Example for
Okay.
mechanical wave: water wave and sound wave, and waves that propagates in the strings during its vibration. Conditions of mechanical waves: the presence of vibrating bodies, um, like source. I mean, if I don't have a source for the sound, I can't hear the sound. Okay, like
Okay.
thing in the guitar. If I don't vibrate it, I can't hear the wave. I can't hear the sound. The wave can't be transferred from the source to the air to my ear. Okay.
Okay.
Okay. The second condition: a kind of disturbance that can travel from vibrating source to the medium. That type. The third one: the presence of medium. Oh, you should know the mechanical wave can't be transverse in the space. Do you know it?
Yes.
Okay, so why we can see the explosions of stars and can't hear these explosions?
Because sound can't transfer through space.
Okay, excellent,
Needs
excellent.
a-
Okay, so the sound prefer to transfer through wood or air?
through air.
Are you sure?
Sound transfers through air.
Through air. Sound,
سؤال
by
تاني
the way,
طيب.
okay, sound, by the way, can transfer through air or water or solid or through wood. But I ask, what's the faster?
The faster is air.
Okay, to answer, we can do an experiment, a small experiment, okay, to detect the
Okay.
correct answer by practice it. Okay. Okay.
Okay.
يعني I mean not theoretical يعني. Okay. You can knock on any wooden body or wooden object next to you, table, I mean, or desk or door, anything, knock twice and hear a sound.
Yes, I hear some.
I can't hear your knocks. Ahmed?
You hear them?
No. Do you knock at the door or wooden object or something? Okay, I hear it. Okay. And repeat this experiment by putting your ear on this wooden object.
Okay.
Okay. What is more loud?
When I put my ear on the wood,
Why?
because sound transfer faster through wood.
Okay. Do you know why? Why it preferred solid object to transfer more than gaseous state or liquid state?
No.
Okay. By knowing that mechanical wave or especially sound wave can't transfer through space, then the state which has more space through it, it can be harder for mechanical wave to pass through. Then which one has less or the least spaces between them?
Solid.
So okay, excellent. Another experiment, but we can't do it. Okay, but notice all only. Okay, 1 second.
Take your time.
Okay. Do you know the biggest bird? The ostrich?
Stretch. Yes, I know it.
Okay. The ostrich, when it see a hunter coming toward it, what it do or does? It put its head into
Its head
sand.
in the ground.
Okay, why? By the way, because of it isn't be stupid or to be more easier for hunting. Only it know that mechanical wave can transfer more easier in solid state. So it move far away gaseous state like air into solid state like sand. For why? Paul can detect the steps of the hunter more accurate. Do you know it?
Yes, yes.
اوكي. احمد احنا بس هنقفل الميتنج وهندخل تاني على نفس اللينك عشان انت عارف موضوع الزوم بيفصل بعد 40 دقيقة، فعشان نتجنب الموضوع ده بنفصل بعد نص ساعة. اوكي
تمام
على نفس اللينك، ما تروحش في اي حتة.
تمام.